Okay, today we're going to review for the chapter 3, 1 through 3, section B test, part B test. This part B test, you will have a graphing calculator, and when in doubt, graph it out. So if you are confused and you are not certain and you feel like your brain is playing tricks on you, when in doubt, graph it out and don't rely just on your brain. Double check it in the calculator to make sure that you know what you're doing. Do we all understand what I just said? Any questions over that? Okay, now, if we're going to get out your review worksheet, Okay, I'm going to keep on going with this review worksheet right now. Number one, it says write each logarithmic equation into an exponential equation. How do I do that? Someone help me out. The base is 3, the exponent is across the equal sign, and that is equal to 81. Can you do that? Number 2, how is number 2 different than number 1? That ln is understood to be log base e, so log base e of 1 is equal to 0. So how do I write that logarithm as an exponential? E to the 0 is equal to 1. Do I have to write this step right here, the first step that I showed? No, if your brain automatically knows that natural log is log base e, hallelujah, praise the Lord, we finally got through to you, that's awesome. If you can't see that and you have to take that extra step, do it, I don't care. This is going to be your answer. Do you understand that, yes or no? You will have one problem where it says write that from an exponential to a logarithm. Can you do it? Okay, backwards. Write each exponential equation in logarithmic form. Now I want you to give me the logarithm that matches that exponential. So log base 9 of 27 is equal to 3 over 2 is correct. What about number 4? Log base e of 4 is equal to x, so that's the natural log of 4 is equal to x. Do we understand that, yes or no? Can you do it? Any questions? You have one problem like that. The next thing, we already did those problems yesterday. So that is going to bring me to today's, which is going to be the graphs. Okay, now let's talk about our graphs a little bit. You have 4 problems that are graphs. You have 2 exponential and 2 logarithms. Now, I'm simply going to come over here. I'm going to do y is equal to 2 to the x. And then I'm going to do y is equal to log base 2 of x. Those 2 functions are inverses. Do we all understand that? Since they're inverses, what I know this is going to be my exponential, and this is going to be my logarithm. We know that because we know that those are what exponentials and logarithms look like, yes? Do we all understand that? Now, with that being said, the next thing that you need to get is going to be, what is my domain of my red exponential function? I have domain, range, asymptote, and the next thing I need is going to be intercept. Okay, so can anybody tell me what my domain of the red function is going to be? It is negative infinity to infinity, and the reason why is because we read domain from left to right, and there's arrows extending in both directions, so it goes on forever. Yes? We know that. Now, the next thing is let's talk about our asymptote for an exponential function. An exponential function has an asymptote changing when you move the function vertically up and down. Do you all understand that? So did I move this function up or down? I did not. So when do I first run into this graph at? I run into this graph at 0 and I stop running into it at infinity. The problem is it cannot be 0 for my range. And the reason why it cannot be 0 is because this function is going to get ridiculously close to it, but it is never going to cross 0, which is why I have y equaling 0 as my horizontal asymptote. Do we all understand that? And since y equals 0 is my horizontal asymptote, this is never going to cross my x-axis. So therefore, the only intercept that I'm going to have is going to be a y-intercept. Do we all understand that? How do you find a y-intercept? A y-intercept is found whenever x is 0. So when x is 0, that's going to be 2 to the 0 power, which is 1, to give me the ordered pair 0, 1. Bless you. Do we all understand that? Now, With all of that said, now let's talk about our logarithmic function. Our logarithmic function right here is going to be log base 2 of x. We know that the domain, range, asymptote, and then intercept is what I need. Do we all understand that? Now, my domain is going to be what? My range is going to be what? Which one is easier to read, domain or range at this moment? Okay, so what is my domain of this function, do you think? No. The reason why is because when do I first run into this, Cheyenne? Yes, these two items are going to flip whenever we're talking about our logarithmic function. So our range is actually going to be from negative infinity to a positive infinity because these arrows go in both directions, up and down. Do we understand that? Okay, which means my domain, I do not run into this graph until the value is 0. But it cannot be 0 because I have an x equals 0 asymptote, vertical asymptote. And when does my vertical asymptote change whenever I'm talking about a logarithmic function? If my exponential asymptote changes by moving it up and down, the inverse of an exponential is a logarithmic function. So the opposite of vertical up and down is going to be horizontal left and right, which means this is going to change when I move this function left and right. My logarithmic asymptote is going to change when I move this function left and right. Now, so instead of having a y-intercept, what am I going to have for my logarithmic function? An x-intercept. And how do we find an x-intercept? Nope. An x-intercept is found whenever y is equal to 0. Yes? Wrong function. So this says I'm going to have 2 to the 0 power is equal to x. So what is 2 to the 0 power? 1. So therefore I'm going to have 1 comma 0. Do we all understand that? Now that is what I taught you about exponential and logarithmic functions. So everything that you are going to be doing today, you should be able to do without the graph, 1. And 2, you should be able to verify it by when in doubt, graph it out. Do you all understand what I just said? So if I go back to our worksheet and I go ahead and I look at number 13, you will have 2 exponentials that you have to graph and 2 logarithmics that you have to graph on the test. So if I look at number 13, can anybody tell me what is happening to that function? It's going to go up 1 and right 2. Do we all understand that? So if it's going to go up 1 and right 2, I went from having this exponential function to now having this exponential going up 1 and right 2. Do we see that? Yes or no? And actually, that is a little bit off. So I should probably draw that a little more accurately. The red graph is what we're actually graphing there, okay? So what that means is my domain, my range, my asymptote, and my intercept. And actually, I'm going to put down both intercepts so that you understand. I have an x-intercept and I have a y-intercept. What's the domain of this red graph up there? It is negative infinity to infinity. And what is the range of this graph? Well, your range is basically played out by looking at your asymptote. What is my horizontal asymptote here?
1.
It is going to be 1, so that's going to be y is equal to 1, which means my graph doesn't start until the 1 value, 1 to infinity. Do we all understand that? And do I have an x-intercept or a y-intercept? My x-intercept is none, and my y-intercept is found by letting x be 0. So when 0 minus 2, that gives me 3 to the negative 2 plus 1. What is 3 to the negative 2? It is 1/9. So if I add 1/9 plus 1, that's going to give me the ordered pair 0, 1, and 1/9. Do we understand that, yes or no? We good with that? Because an exponential function always has a y-intercept. The base function, which is 2 to the x or 3 to the x, always has a y-intercept of 0, 1. So that ordered pair is 0, 1, which was right here. Do you see that? I had put a dot on there. I said I was going to go up 1 unit and to the right 2. So that's why I have that dot right there. Does that make sense? Yeah. Okay. So all you have to do then is if you pull up your graphing calculator, and you want a graphs page, you're going to graph 3 to the x minus 2 plus 1. There's your function. If I go ahead and hit Control T, could I now pull up several different x values that are easy for me to graph? The very first one that I want to pull up is going to be when x is equal to 0. When x is equal to 0, I have 1.1111111. What is that numerically? Well, I'm going to go ahead and hit my 1/9 here is 0.11111. So my lovely y-intercept of 1 and 1/9 is actually the decimal 1.111 repeating. Do we all understand that? So I know that I was correct on that, and I would simply pull numbers that are easy for me to graph. 2, 2, 4, 3, 4, 4, 10, and then I would be done graphing. Do we all understand that? Yes? Be very easy. So that is your exponential. You have 2 of those tomorrow. Okay? Now let's keep on going and let's talk about our logarithm. So I'm going to scroll down here and we're going to talk about number 15. If we're talking about number 15, I have log of base 6 of x minus 2. What can you tell me is happening to that function? Up, down, left, right, stretch, compress, reflect. Fun. What do you think is happening to it? I have minus 2 inside with the x. It's going to the right 2 units. Well, if you're a logarithm and you're going to the right 2 units, what does that impact? It impacts my asymptote, right? My horizontal shift on my logarithm affects my asymptote. So instead of having an asymptote at x equals 0, what's my now new asymptote? X equals positive 2, because you're going to the right 2. You're going to the right 2. So if I'm going to the right 2, it was here. This right here was my graph. Do we see that? If I'm going to the right 2 units, I went from there to here. Do we see that? Yes or no? Okay, so if that's my new graph, what is going to be my domain? When do I first run into that graph at, the green graph? What x value do I start to run into it at?
No, 2.
Positive 2. So I'm running into it at 2 to infinity, but it cannot be 2. And what is my range? These arrows are going to be from negative infinity to infinity. And then my x-intercept and my y-intercept I need to look at. Do I have an x-intercept? Meaning, does this thing cross the x-axis? Yeah. My green graph does. And that's going to be whenever y is 0. Well, if y is 0, this is going to be 6 to the 0 power is equal to x minus 2. Well, what is 6 to the 0 power? 1. So 1 is equal to x minus 2. Add the 2 over. So you have 3 is equal to x. So I have the order pair 3, comma 0. Can I check that graphically?
No.
Absolutely. Do I have a y-intercept?
No.
Why?
Because it's too away from me.
It can never get close enough to the y-axis because I have a vertical asymptote at x equals 0. So therefore, or x equals 2. So this is a none. So when in doubt, graph it out. I'm going to come back over here to my graphing calculator. I'm going to control doc and I'm going to add another graphs page. I'm going to hit control 10 to the x and put a base of 6 there. Arrow over and make this x minus 2 and hit enter. Do you see that this is going to be my graph? Now, I can go ahead and hit menu, trace, graph trace, and I can put a 3 in there. When x is 3, what is my y value? 0, meaning my x-intercept at 3, 0 is correct. I can go ahead and hit control T, and I can confirm that on a lovely little table as well. Why are there a whole bunch of errors there? What does the hashtag arrow mean? Hashtag ERR. I'm sorry? It doesn't exist. My graphical logarithm function does not even happen until you are above the value 2. At the value 2, I have an asymptote. It is undefined, meaning you are dividing by 0. Can you ever divide by 0? There is an asymptote there. It's not an error. It says undefined, meaning asymptote. However, at 3, I can see that I have an x-intercept at 3, 0. You all understand that? And then I can simply go ahead and find the rest of those points and graph the number 8, 1. The rest of it's probably going to be nasty numbers too. Do we all understand that? Yes or no? Okay. When in doubt, graph it out. This is not meant to be terribly hard, not meant to be mind-blowing. It's just something you do have to know. So you have 2 logarithms and 2 exponentials to graph and find the domain, range, asymptotes, and intercepts. Okay, that brings me to my next concept, which is going to be number 21. Nope. Use the properties. I'm going to skip 23 through 26, only because I'm going to spend the majority of the time on expanding and condensing so that you guys know what you're doing. Would you like me to do one of the problems from 23 through 26? Can you pick one? 23? 23. I have log base 4 of 8. So log base 4 of 8, 8 is going to be 4 times 2. Would you agree? And log world multiplication means what? So that's log base 4 of 4 plus log base 4 of 2. Yes? Okay. Now, what is log base 4 of 4? It cancels out to give you what value? When you say it cancels, what value is it? It is a 1. So this is going to be 1 plus log base 4 of 2. Done. Okay. Your homework?
No.
Okay, expanding and condensing. So if we're expanding and condensing, which one would you like me to do? 27, 28, or 29? 29, I heard? Okay, so if we're doing 29, I don't have a lot of room there. So I'm going to go ahead and there's my 29. Okay, what do you notice about this first? I'm sorry? The division. So in log world, what is division? So log base b of the square root of x, y to the 4th, minus log base b of z squared. Okay, what's the next thing you notice? So x and y are attached by multiplication, so in log world that is addition. Okay, what's the next thing you notice?
Square root x.
What is the square root of x?
1/2.
Log base b of x to the 1/2 plus log base b of y to the 4th minus log base b of z squared. Now what? All of the exponents are going to go in front of the logarithms by multiplication. So 1/2 log base b of x plus 4 log base b of y minus 2 log base b of z. This is an example of expanding. Can you do that tomorrow for the test?
I have a question.
Yes.
Why don't you put brackets around the first step?
It's not going to matter because whenever you do any order of operations,
Yeah,
which direction do you work from?
I just know because on Math Excel, you didn't put brackets in.
Okay. I will not count it wrong on the test because whenever you're working, you're always working from which direction? Left to right. Left to right. So if you want to put parentheses around this, you may. The parentheses really don't do much to the problem. The significance are irrelevant because you always work from left to right anyway. Okay? Any questions over that? Okay, let's go back over here. We're going to keep looking at condensing now, 30 through 33. Do you have one that you'd like me to do? I'm sorry? 30 is not very hard. I'm going to choose to do 32 because I think it might surprise you more than anything. Okay, is that all right? Okay. Now, if we look at number 32, what can you tell me? What do you notice about 32? Subtraction. How many different times do you see subtraction?
Twice.
Twice, but we always have to work from left to right. We have to look at our parentheses first, yes? So if I just copy down this 2, I'm going to see in this parenthesis, the first one I have subtraction. So in log world, what is subtraction? So that's 2x over y minus log base 3. What's this 2 going to do? Correct. So plus log base 5 squared. Okay. What's the next thing you're going to do? Okay, so I'm going to leave that other parenthesis here. Minus, this is going to be log base 3 times 5 squared. Would you agree? Okay, well, what else?
The 2 on the outside.
The 2 on the outside is what?
It would be an exponent to 2x over y, which is the square root.
So you're going to take 2x and square it, and you're going to take the y and square it, minus log base 3 times 25. Why is that 25? Because 5 squared is 25, correct? Okay, well, what is 2 squared? 2x squared. I'm sorry? 4x squared. And this is going to be the log of 75. Now, how are those attached?
Subtraction.
And what is that in log world? Division. Okay, now watch. Log of 4x squared over y squared divided by 75. When you divide by 75, what are you actually multiplying by? 1/75. So what you actually have is going to be log of 4x squared over y squared times 1 over 75, which is simply log, is this a b? Or is this just log? Log of 4x squared over 75 y squared. That is done. So is that a little bit more involved than what you thought it was? Do we understand that condensing? You have 2 of those on the test tomorrow. You have 2 expand and 2 condense. Can we do it? Okay, the last part of the test that we need to focus on is going to be our lovely little it's going to be our interest, okay? It's going to be our interest. You have 2 formulas whenever you're talking about interest. You have A is equal to P parentheses 1 plus R over N raised to the NT. And you have A is equal to PERT. When do you use each of those formulas? Okay, the top red one is going to be whenever we're using the terms such as annually, monthly, quarterly. Does that make sense? Biannually. Those are all examples of when you're going to use the top red formula. If you see the words continuously compounded anywhere in your story problem, then you are going to be using the bottom one, which is calculating your interest on every second of every minute of every hour of every day. That is going to be your continuously compounded PERT formula. We all understand that. Okay? Now, with that being said, let's go back up to this problem. It says complete the table to determine the balance A for 2 years compounded continuously. If it's compounded continuously, which formula am I utilizing? I'm going to be utilizing PERT. So A is equal to PERT. And I'm going to simply put in my numbers. What is P representing in this problem?
Excuse the interruption. My name is Robert Abel. Corey.
Again, what does the P represent? In this problem, what is P? It is the amount that we initially invested, the $32,500. E is going to be our number 2.718 that we're going to utilize in our calculator. R is going to be my interest rate. Can I use my interest rate at 6.25%? No. What number am I having to plug in for that? Very good. So this is 0.0625, and T is going to represent my time. My T, which is my time, changes every year or every problem, doesn't it? So this is what we're going to let be our variable. And instead of T, I'm going to write the number X. Why am I letting that be X? Because we're going to use our calculator to help us calculate the rest of those instead of doing it all manually. So I'm going to come over to my graphing calculator. And I'm going to Control Doc, and I'm going to get a new graphs page. And I'm going to type 32500. No, 2 zeros. E to the 0.0625 times X, and hit enter. I don't care what the graph looks like, do I? What I care about is Control T, which is going to be all the evaluations that I need. So you need to be very careful, and you need to make sure that whenever you're doing this, that you write down the cent to the nearest cent, right? So I want dollars and cents on this. So after combining it one time of year, I'm going to have $34,596, and look down here at the bottom, and 7 cents. When I do it biannually, I click on that cell and I have $36,827.32. When I do it 3 times a year, it's $39,202.48. On your math Excel, this is like problems 23 and 24. You had to arrow up once on your calculator to enter, and it would give you that long decimal. You all understand that. And if you didn't get that long decimal, then you probably got the problem wrong several times because you didn't get the right cents in there. Dollars and cents, you got to have all the way to the hundreds. Okay? Any questions over that right there? Now, the last part of it is going to be this right here. Oh, maybe I should go by tens on there. I want you guys to see that. See how it's 1, 10, 20, 30, 40, 50, so it wants to know how much you have in your account after 40 years? Okay? So since this is continuously compounded, this is going to be your time of years that it's in your account. So if I hit Menu and Table and Edit Table Settings, if I want to start at 10 and go by increments of 10 and hit OK, it makes life so much easier. So after 20 years, I'm going to have $113,436.15. And then you can see the 50 years and so forth. Do you all understand how to use your calculator for that? Excellent. Okay, this problem, what's going on with this one? Complete the table to determine the balance A for P dollars invested at rate R for T years compounded N times per year. So for problems 1 through 12, I'm going to use this formula. And then for the very last one, I'm going to use A is equal to PERT because it says continuously. Do we understand that? Yes or no? So you have 2 different formulas you have to use in this problem. Are there any questions over these? Yes or no? Your test tomorrow, you will have at least 5 of them. And that's the test. The test, literally, there are going to be 15 questions. Now, how do you prepare effectively for this test tomorrow? You need to make sure all of your homework is done. 3-3 worksheet, or you should say 3-1 worksheet 1, 3-2 worksheet 2, 3-2 worksheet 2, 3-3 worksheet 1, math Excel, and your review worksheet over sections 1 through 3. Yes? Test is tomorrow. You will have the whole period to complete it. If you have any additional time left, if you need to finish anything else, you may do that. Are we good? All right, the rest of the time is yours to study.